Welcome back. This is Professor Ridge and today's lesson on section 5.7, Factoring a General Strategy. Okay, so now that we've did all the different types of factoring, we're going to put them all together into one chapter and mix them up and see how you do. So first, let's go through the strategy and how you approach a factoring problem. Okay, so we start with factoring out any greatest common factors, if there's any. Okay, so you always look for common factors. That's always your first thought. Okay, any GCFs, you look at all the terms, you factor it out. And the next thing, then you look for the number of terms. Okay, so if the thing you're trying to factor has two terms, you're going to look to see if it's a difference of squares, see if it fits that formula, or sum or difference of cubes. So you try those. Here, I'll write them down for you. Okay, so now for three terms, so if it has three terms, then you look here. Your first thought is it a perfect square? So you see if it fits that. This is the way I like to say it. If it fits perfect square trinomial. Meaning, does it fit this or formula or pattern? Is it a squared plus 2ab plus b squared? If it's that, then it's a plus b or squared, a plus b. Should have used the square there. Same thing. And then, of course, if it's minus, a minus b squared. Okay, if it's not a perfect square, then just do the Ridge method or just the general factoring for trinomials, the reverse FOIL. Okay, so if it's not a perfect square, again, you can use that reverse FOIL, that trial and error method, or the way I showed you, the Ridge method, the way I do it. Okay, preferably that way. Alright, what if it has four or more terms? So if it's four or more terms, you try factoring by grouping. And then this step is you always factor completely. So if the directions say factor or factor completely, it doesn't matter. That's irrelevant because the factor means you factor completely. So I always get questions about that. And just right here it is, right? The process for factoring is you factor completely. So you always factor completely. And then the final step is you can check the problem by multiplying. Now the only problem with the check is just seeing that if you factored that step correctly, but that doesn't necessarily tell you if you factored it completely. So, you got to be careful. Always factor completely. Okay, let's try a few and see how we do. So let's start with number 18 in the book. Okay. So it's factor. All these are factor. So number 18 from the exercise set, t to the 5th minus 49t. So our first step is look for common factors. So you can see they both have a t in it, so you factor out a t. And you get t to the 4th minus 49. Okay. Our second step is you count the number of terms. There's 2 terms that we're factoring. We just bring that t down. And we look to see if this fits the difference of squares pattern. And then you notice d to the fourth square, 49 is a square. So you square root both. So, and then plus, minus. And then we want to see if we factor completely. Sum of squares you can't do. We should write that up here. Note. A squared plus b squared can't do. Okay. Then we look at the minus one. Well, the 7's not a square, so you can't factor it anymore. So you're done. And if you want to multiply it out, you can check it. So if you multiply it out, you get t to the fourth minus 49, and then distribute the t, and you get t to the fifth minus 49t. So that checks out. All right, let's try another one. How about 22? So let's see, any common factors? Just the a. So we get 8a squared minus 18a minus 5. So we check to see if this, we count terms, 1, 2, 3 terms. So first see if it's a perfect square trinomial. And right away I know no, because the 5 is not a perfect square. Neither is 8. Okay, so now I'm going to do ridge method. 8 times 5 is 40. Factors of 40 that subtract. Factors of 40 that subtract to 18. Again, I wouldn't normally write this, just thought process. So let's see, 40 would be 1 and 40, 2 and 20. That's it. So I'm going to get 8a, 2 and 20. I'm going to divide it by 8. Right, 8, doing the ridge method. Put in my signs. Bigger one gets the same sign as b. Signs are different. To get -5, these have to be different. Okay, now to save space, I normally just write right above it. So what comes out of 8 and 2? So that is 2, and I'm going to get 4a plus 1. And then what comes out of 8 and 20 is 4. I'm going to get 2a minus 5. So the 4 and 2 make 8, cancel the 8 on the bottom, and I'm left with a, 4a plus 1, 2a minus 5. So that's kind of all scratch work right there. This is my answer. Alright, let's try another one. Next page. Okay, let's look at 31. X squared, so I got 1, 2, 3, 4 terms. Oh, first, is there any common factors? No. So B, 4 terms. So all I try is factor by grouping. So our first step is to look at this. And let's see, we get x plus 6. Nothing comes out of that. So that's not going to work. So what I notice is, oh, if I switch the y and the 9, and it's not going to work grouping 2 groups of 2, so I'm going to rearrange the groups. I'm going to switch the 9 with the minus y squared, and I notice that this is a perfect square trinomial. So this is going to become a difference of squares. See, x squared, square root of 9 is 3, and then I check the middle term, 2 times x times 3 is equal to the 6x. So this fits. Or if I do the thought process, factors of 9 to add the 6 is 3 and 3. And both signs are the same. So anyway, hopefully you get some practice with that. And so now I see that I have a difference of squares, and I'm thinking of this x minus 3 as one number. So what I get is, it's x plus 3, sorry. X plus 3 plus y, it's a plus b, a minus b. And that's my answer there. Let's try another factor by grouping. So our first step is to take out common factors. They all have a 3. So divide 3 out of each term. Okay, then we have 4 terms, so we're going to do grouping. So again, I'm going to try 2 and 2, see what happens. So we'll see out of the first 2 I can take x squared divide out x from both terms, so you're left with x plus 2. And the second one, again, rule of thumb, first term's negative, you want to take out a negative. And they both divide by 9. And our goal is that we're going to be, let's see, so we're dividing both by 9. So that'll be x, we'll divide by negative 9, so plus 2. And our goal is that if this parentheses match, then we can factor out. So we'll bring it out in front. And then what's left inside the parentheses, if you cover those x plus 2's up, those 2 becomes the 1 that I brought out. And then what's left over is x squared minus 9. Now again, okay, so that's b. Then you got to look, can you factor more? Are you done? And the answer is, well, this is the difference of squares, so I can factor that one more time. So x plus 3, x minus 3. And now it's done. And of course, I can multiply it all out to check if I want. So I'd usually do that on scratch paper. Okay, so 51. Common factors first. Let's see. They both divide by 2. So 27a cubed minus 8b cubed. Now we have 2 terms, so first see if it's different squares. No. Then you look, okay, those are both cubes. So I use my cube formula. And if you remember, you cube root each term, so we get 3a minus 2b. Now I'm going to look at the first term in the parenthesis, the a, 3a, and square it. That's 9a squared. Then I multiply these 2 together, change the sign, so that would be 6ab, and then I square the last term, 4b squared. And that is factored completely, so I don't need to go any further. And that's done. Alright, for 61, there's no, you need to start thinking about parentheses as one term. So usually what I do in class is I write this down right next to the problem like I'm going to do. And if I ask you to factor wx plus wy, everybody has no problem saying, oh, that's wx plus y. But then when I ask 61, everyone looks at it like it's something super hard and crazy. Well, it's just that you're not familiar with it and you're not looking. If you think of this as the w, see, they're the same. That's w. So you factor that w out, which is a minus 3. And if you think of this as x and this one as y, then you have x plus y. Now inside this bracket there, you can simplify. You can drop the parentheses, the inner parentheses, because it's just plus, and then combine like terms. You got a plus a is 2a. 7 minus 1 is 6. Now be careful. If you just left your answer here, it'd be wrong, because you got to always factor completely what comes out of these two numbers, and then just bring it out to the front. Now, typically, a beginning student would multiply a minus 3 times a plus 7, multiply it all out, multiply out the second a minus 3, a minus 1, combine all the like terms, and then factor it, and you would get the same answer. But believe me, it'll take you a lot longer. If, as a challenge, you can multiply these two out, combine all your like terms, and then factor the result of that, and you'll see you get the same answer. Okay, so that concludes the lesson for 5.7. Go to my math lab and complete your exercises there, and I'll see you next time.